Welcome everyone to the discussion of my paper Measuring Macroeconomic Uncertainty Across Country Analysis. I am Andreas Dibiasi, and this is joint work with Sarferaz, a former colleague of mine from the ETH in Zurich. This paper is a contribution to the uncertainty literature, and it has two large contributions. The first one is we construct a measure of macroeconomic uncertainty that is available for many countries over a long time horizon that is consistent across countries. Moreover, it corresponds to the theoretical notion of uncertainty. The second large contribution is that we highlight the importance of the employment channel for the propagation of uncertainty shocks. We show that stricter employment protection legislation might actually mitigate the negative effects of uncertainty on the economy. How do we do that? In the first part, we extract the unpredictable part of revisions in real GDP, and we compute the conditional volatility of this unpredictable part and treat it as a measure of macroeconomic uncertainty. The advantage of this approach is that it builds on the system of national accounts, a system that is highly standardized across countries, available for many countries over a long time horizon. Once we have the set of uncertainty indicators, we study the effects of uncertainty on the economy. We show that uncertainty shocks have actually negative effects on the economy, and we finally highlight the importance of firing costs for the propagation of uncertainty shocks. So how do we get from data revisions to uncertainty? We argue that the first release of GDP is nothing else than a forecast provided by the statistical agencies for the last release of GDP. So why is that? Statistical agents usually publish the first GDP figure of a quarter 1 month after this quarter is finished. At that point in time, statistical agents do not have all the data about this given quarter. Over time, information keeps flowing in, and their estimates or calculations get more precise, until eventually statistical agents have all the information about the given quarter and they can compute the final release of GDP. So the first release is nothing else than an estimate of the final release of GDP. We know from the literature that one can think really structurally about these revisions and decompose revisions into news and noise, with revisions that are due to noise being revisions that are because of measurement error or really these classical errors in variables. On the other hand, we have revisions that are because of news, and these are the rational forecast errors, and this is what we are after. So in order to back out this news from the revisions in real GDP, we extend the model proposed by Jacobs and Van Noorden to model data revisions, and we extend it by introducing time-varying error variances for newses and noises and time-varying coefficients. The time-varying error variances of the newses, of the rational forecast errors, will eventually be our measures of uncertainty. We estimate this model using real-time data. So for this project, we had to build up our own real-time database, which consists of the data provided by the OECD main economic indicators database starting from 1999 onwards, but the data before 1999 we had to tediously collect from country-specific sources. Overall, we have 39 countries in our database. So how do our uncertainty measures look like? What I brought you here is the uncertainty indicator for the United States. In blue is ours, and we already compare it to the uncertainty indicator, macroeconomic uncertainty indicator for the United States, provided by Jurado, Ludwigsen and Eng. You see that both indicators highly correlate. There are also some dissimilarities. Ours highlights more the uncertainty in the 70s, whereas the indicator by Jurado, Ludwigsen and Eng peaks during the beginning of the 80s. Otherwise, the correlation is quite high. This is not the case if we compare our uncertainty indicator to other uncertainty indicators, such as, for instance, the Economic Policy Uncertainty Index for the United States, provided by Baker, Bloom, and Davis. Also, if we compare our uncertainty indicator to the VIX, which is the implied volatility of stock options, an indicator that is often used as a proxy for uncertainty in the literature, you see that the correlation is not that high. The VIX, for instance, spikes on much more occasions than ours. So once we have our uncertainty measures, we want to study the effects of an uncertainty shock on the economy. We do so using a VAR analysis. We take a VAR specification of the literature and we plug in our uncertainty indicator. First for the United States and then for the G7 countries in a panel VAR setting. For the United States, we find that the one standard innovation of our uncertainty indicator leads to a drop in GDP, investment, employment and consumption, with investment reacting more than GDP and consumption reacting less than GDP. This is a finding that has already been found by other studies. The nice thing is that if we replace our uncertainty indicator in the VAR analysis with the indicator provided by Gerardo, Ludwigsen and Eng, we get the same results as you can see here in green. Meaning that our uncertainty indicator has basically the same information than the macroeconomic uncertainty indicator provided by Gerardo, Ludwigsen and Eng. We take this as a confirmation that our approach to capture macroeconomic uncertainty actually works. We also study the uncertainty shocks for the G7 countries. Here we find the same result. An uncertainty shock leads to a drop in GDP, investment, employment and consumption, with investment reacting more than GDP and consumption reacting less than GDP. Once we have established that uncertainty shocks are actually bad for the economy, we want to focus a channel connecting uncertainty and the economy that so far has not had the attention that it actually should have had, the employment channel. We highlight the importance of firing costs for the propagation of uncertainty shocks. How do we do this? We take the 9 countries with the longest time series and we divide them into 2 groups according to the employment protection database of the OECD. The first group of countries has a relatively high labor protection and includes countries such as Germany, France, Italy, Sweden and Japan. The other group of countries has relatively low labor protection standards and includes countries such as the US, UK, Canada and Switzerland. For both groups, we estimate a panel VAR and look what we find. On the left-hand side, you see the impulse response functions for the countries with high labor protection. On the right-hand side, you have the impulse response functions to an uncertainty shock for the low protection countries. Note, an uncertainty shock in the low protection countries has more negative and more persistent shocks on the economy compared to an uncertainty shock in the high protection countries. In the paper, we discussed this also in a more theoretical way. We use the really uncertain business cycle model proposed by Bloom and co-authors 2018. And this is a real business cycle model with heterogeneous firms and a representative household. Firms are endowed with a Kappa-Douglas production function and they face a productivity process that has a macro and an idiosyncratic component. And both components vary over time in the first and second moment. So an uncertainty shock in this model is the increase of the variance of the shock distribution from which future realizations of the productivity are being drawn. Firms observe these draws of productivity and they react to them by adjusting capital and labor. However, adjusting capital and labor is costly. And this is the nice feature about this model because it features many labor and capital adjustment costs. So what do? In a first step, we calibrate and estimate the model as it is. In a second step, we increase the firing costs from 2% of an annual wage per worker fired to 4% of an annual wage per worker fired. This increase is really not a lot. In Europe, for instance, we can find values up to 10% of an annual wage per worker fired. But look what is happening if we increase firing costs only by that little. The blue impulse response functions are the original specifications with low firing costs. The gray ones are the impulse responses with higher firing costs. You see that if we increase firing costs, the effects of an uncertainty shock on output, employment, and to some extent also investment decrease. Now what is going on here from an economic point of view? So by increasing firing costs, we make it more expensive for firms to lay off workers in the light of an uncertainty shock. These firms, they fear the costs of firing a worker, that they might eventually have to hire again once the uncertainty resolves. So it's optimal for them to actually stick to this worker and not to fire him. So in the model with higher firing costs, less workers are being fired, there's more production, there's more income, there's more consumption, and the economy overall decreases by less. So let me just conclude and summarize what we actually do in this paper. First, we extend the news-noise model of data revisions by Jacobs and van Noorden by including time-varying error variances and coefficients. We use this model to compute consistent and direct measures of macroeconomic uncertainty for 39 countries. We use this cross-country nature of the dataset to study the effects of uncertainty on the economy. We find that uncertainty shocks actually have negative effects on the economy. And finally, we highlight the importance of the employment channel connecting uncertainty and the economy. We provide evidence that stricter employment protection legislation might actually mitigate the negative effects of uncertainty on the economy. And this has direct policy implications. A policymaker now does not only want to take into consideration the level, the amount of uncertainty in an economy to formalize its optimal policy response, it also wants to consider its level of employment protection. Thank you.